So here are we, our group 10 for the interactive data science group. Our project starts with the musical characteristics. So in recent years, the music streaming platforms have transformed the way we listen and understand music from a global perspective. Spotify, serving as the largest musical streaming platform in the world, which is a perfect example for us to increase our visibility and overview of the music industry and cultural development. However, while the cultural and linguistic factors clearly shape musical preference, an interesting question remains unexplored. Does economic prosperity influence what music people prefer? So, this question has significant implications across multiple domains. And in this project, we investigate the relationship between national music preferences and economic prosperity by analyzing Spotify's top trending songs across 73 countries alongside the World Bank GDP per capita data. Our central research question is, to what extent does the economic prosperity correlate with and predict national museum preference patterns? So to answer these questions, we developed this an interactive Streamlit dashboard that enables users to explore correlations, visualize geographic patterns, compare country distributions, and train the machine learning models to predict GDP from musical features. Thanks.
Okay, so for the data visualization methods, we actually develop an interactive multi-page Streamlit dashboard. And actually, for the first pages, we included correlation analysis and display chart showing the overall correlation and time series plot showing the temporal trend with different features. While in the feature versus GDP relational panel, and the relation between each feature and country GDP is further expanded. So you can see in this. And we can choose a different number of clustering centers. It can also be visualized in the stack plots and colored on the map. And actually, the map can either be colored by the musical feature or the GDP clusters. So this is how we cluster by doing the coloring by the GDP cluster. And we can also choose to color by the musical features. And we can change any features to visualize and change the number of clusters. And afterwards, we can compare the distributions of those features across one countries or different countries. So you can either select the single country bottoms. For example, we choose Argentina, we can see the distribution for all the music features. And we can also choose two countries, for example, the Australias and Argentina. And we can see how the distribution actually changes. And yeah, so we also have similarity scores between two distributions. And afterwards, we can predict the GDP using those music features. So you can choose arbitrarily any number of the features to be included in the training sets and test sets. And you can add or delete any one of them and choose any among these four models. And so on the right side, to increase the explainability, we also include the chef values regarding each musical features. And lastly, we have musical characteristics by country over time, which is a very beautiful plot. And we can choose any features to visualize and just click these round buttons. And it will show the trends from the 2023 to 2025, how this kind of changes in this kind of features within different countries. And we also have a summary pages to share our key findings in this panel.
So now we are going to show our main results of the project. In this page, it presents the distribution of musical characteristics of different countries in an interactive format. For instance, the United States and Australia have comparable economic levels, and their distributions of all music features are very similar, with similarity scores above 0.97 in all cases. Yet, compare Indonesia with the United States, their economic level vary greatly, and there are also significant differences in the distribution of acousticness and valence. We use these musical features to predict GDP. We find that there is a relative obvious correlation between GDP and music features, and also a certain causal relationship is presented. So when valence, speechness, and acousticness are selected as training features, The result of AdaBoost model can reach R squared of 0.3975. However, the features and models need to be chosen carefully, and in most cases, using music features to predict GDP will not yield ideal results. Finally, we discuss the changing relationship between music features and time. Just as GDP evolves over time, so do countries' musical preferences. In general, the preferences of most countries are relatively fixed, although the values of each feature fluctuate from time to time. Brazil, for example, has always had a clear preference for high-energy music.
Previous research suggests that music genres and regional culture are often related with economic factors. However, this pattern is not verified at the global scale. But in our system, users could directly compare musical features with economic indicators and discover unexpected inverse relationships, which are against the cultural stereotypes. The correlation in the country and temporal dashboard encourage new analytical practices, such as comparing temporal stability across months, examining feature level trends instead of genre level assumptions, and identifying which musical characteristics consistently synchronize with socioeconomic factors. A prediction of GDP based on music preference is also provided, which serves as a fun and novel point of view. So, all in all, this allows users to move beyond anecdotal reasoning and adopt a more practical approach to understanding global music taste and its relationship with economy. So that's all of our demonstration, and thank you for watching and listening.